Top 25 Electronics Interview Questions and Answers. Welcome back to the channel. If you're preparing for an electronics interview, whether it's for a diploma, bachelor's degree, or a technical job, this video is exactly what you need. Today, we'll cover the top 25 electronics interview questions and answers, explained in a simple, practical, and easy-to-remember way. Each answer is designed to help you understand the concept clearly and confidently explain it during your interview. So grab a notebook, stay focused, and let's get you interview ready. 1. What is electronics? Electronics is a branch of science and engineering that deals with the controlled flow of electrons through devices and circuits. It mainly focuses on active components such as diodes, transistors, and integrated circuits, unlike electrical engineering, which often deals with high-power systems. Electronics is widely used in communication systems, computers, medical devices, and consumer appliances. By manipulating electrical signals, electronics enables processing, amplification, storage, and transmission of information. In simple terms, electronics helps convert electrical energy into useful signals for real-world applications. 2. What is the difference between analog and digital electronics? Analog electronics deals with continuously varying signals, such as sound or temperature signals, which can take any value within a range. Digital electronics, on the other hand, works with discrete signals, usually represented by binary values 0 and 1. Analog systems are more susceptible to noise, while digital systems are more reliable and easier to process. Examples of analog devices include microphones and amplifiers, whereas computers, smartphones, and microcontrollers are digital systems. Today, most modern electronics combine both technologies. 3. What is a semiconductor? A semiconductor is a material whose electrical conductivity lies between that of a conductor and an insulator. Common semiconductor materials include silicon and germanium. The conductivity of semiconductors can be controlled by adding impurities through a process called doping. This property makes semiconductors ideal for electronic components like diodes, transistors, and integrated circuits. Semiconductors are the backbone of modern electronics, enabling compact, efficient, and high-speed electronic devices used in everyday life. For what is a diode? A diode is a two-terminal semiconductor device that allows current to flow in only one direction. It consists of a P-type and N-type semiconductor junction. When forward-biased, the diode conducts electricity. When reverse-biased, it blocks current. Diodes are commonly used in rectifiers to convert AC to DC, voltage regulation, signal clipping, and protection circuits. Special types of diodes include Zener diodes, LEDs, and photodiodes, each serving specific electronic functions. 5. What is a transistor? A transistor is a three-terminal semiconductor device used for amplification and switching of electronic signals. It can control a large current using a small input signal. There are mainly two types: bipolar junction transistors, BJT, and field effect transistors, FET. Transistors are essential components in amplifiers, oscillators, digital logic circuits, and microprocessors. Without transistors, modern electronic devices, such as computers and smartphones, would not exist. 6. What is the difference between BJT and FET? A BJT is a current-controlled device, meaning the output current depends on the input base current. A FET is a voltage-controlled device, where the output current is controlled by the input gate voltage. BJTs offer high gain, but consume more power, while FETs have high input impedance and low power consumption. FETs are widely used in integrated circuits, whereas BJTs are often used in amplification applications. Both have unique advantages depending on the application. 7. What is an integrated circuit IC? An integrated circuit, or IC, is a miniaturized electronic circuit containing thousands or millions of components like transistors, resistors, and capacitors on a single semiconductor chip. ICs drastically reduce size, cost, and power consumption while improving reliability. They are classified into analog, digital, and mixed-signal ICs. Examples include operational amplifiers, microcontrollers, and memory chips. ICs are the foundation of modern electronics, and computing systems. 8. What is an operational amplifier? An operational amplifier, or op-amp, is a high-gain voltage amplifier with differential inputs and a single output. It is used in signal amplification, filtering, voltage comparison, and mathematical operations like addition and integration. Op-amps have high input impedance and low output impedance. Popular op-amp configurations include inverting, non-inverting, and voltage follower. Op-amps are widely used in audio systems, instrumentation, and control systems. 9. What is a rectifier? A rectifier is an electronic circuit that converts alternating current, AC, into direct current, DC. It uses diodes to allow current flow in one direction only. There are 3 main types: half-wave rectifier, full-wave rectifier, and bridge rectifier. Rectifiers are commonly used in power supplies to provide DC voltage for electronic devices. Efficient rectification is essential for stable and reliable operation of electronic circuits. 10. What is a capacitor? A capacitor is a passive electronic component that stores electrical energy in the form of an electric field. It consists of 2 conductive plates separated by a dielectric material. Capacitors are used for filtering, energy storage, coupling, and decoupling in electronic circuits. They help smooth voltage fluctuations and block DC while allowing AC signals to pass. Common types include ceramic, electrolytic, and tantalum capacitors. 11. What is an inductor? An inductor is a passive component that stores energy in the form of a magnetic field when current flows through it. It resists changes in current, making it useful in filtering and energy storage applications. Inductors are commonly used in power supplies, transformers, and radio frequency circuits. They work based on the principle of electromagnetic induction. Inductors are often paired with capacitors to form tuning circuits. 12. What is a transformer? A transformer is an electrical device that transfers energy between 2 or more circuits through electromagnetic induction. It is mainly used to step up or step down voltage levels in AC systems. Transformers consist of primary and secondary windings wrapped around a magnetic core. They are widely used in power distribution, adapters, and isolation circuits. Transformers improve efficiency and safety in electrical and electronic systems. 13. What is a power supply? A power supply converts electrical energy from a source into the correct voltage, current, and frequency required by a load. It can be linear or switching type. Power supplies are essential for providing stable DC voltage to electronic circuits. They include components like transformers, rectifiers, filters, and voltage regulators. A reliable power supply ensures proper functioning and longevity of electronic devices. 14. What is voltage regulation? Voltage regulation is the process of maintaining a constant output voltage despite changes in input voltage or load conditions. It is achieved using voltage regulators such as Zener diodes, linear regulators, or switching regulators. Proper voltage regulation protects sensitive electronic components from damage. It is crucial in power supplies, communication systems, and microcontroller circuits. 15. What is a microcontroller? A microcontroller is a compact, integrated circuit designed to control specific tasks in embedded systems. It contains a processor, memory, and input-output peripherals on a single chip. Microcontrollers are used in home appliances, automotive systems, and industrial automation. Examples include Arduino, PC, and AVR microcontrollers. They are programmed to perform dedicated functions efficiently. 16. What is a microprocessor? A microprocessor is the central processing unit of a computer system. Unlike a microcontroller, it does not contain built-in memory or peripherals. Microprocessors are used in computers, laptops, and high-performance systems. They execute instructions, perform calculations, and manage data flow. Microprocessors offer high speed and flexibility, but require external components to function. 17. What is an oscillator? An oscillator is an electronic circuit that generates a continuous periodic waveform without any external input signal. Common waveforms include sine, square, and triangular waves. Oscillators are used in clocks, radios, and signal generators. They rely on feedback and amplification to sustain oscillations. Crystal oscillators are widely used due to their high stability and accuracy. 18. What is feedback in electronics? Feedback is a process where a portion of the output signal is fed back to the input. It can be positive or negative. Negative feedback improves stability, bandwidth, and reduces distortion. Positive feedback increases gain and is used in oscillators. Feedback plays a critical role in amplifier design and control systems. 19. What is a logic gate? A logic gate is a basic building block of digital electronics that performs logical operations on binary inputs. Common logic gates include AND, OR, NOT, NAND, NOR, XOR, and XNOR. Logic gates are used in digital circuits, processors, and memory systems. They form the foundation of computer logic and decision-making processes. 20. What is a flip-flop? A flip-flop is a digital memory element that stores one bit of information. It has two stable states and changes state based on clock signals. Types include SR, JK, D, and T flip-flops. Flip-flops are used in counters, registers, and memory devices. They are essential for sequential logic circuits. 21. What is a PCB? A printed circuit board, PCB, mechanically supports and electrically connects electronic components using conductive tracks. PCBs improve reliability and reduce wiring complexity. They are used in almost all electronic devices. PCBs can be single-layer, double-layer, or multi-layer depending on complexity. Good PCB design ensures efficient signal flow and heat management. 22. What is soldering? Soldering is the process of joining electronic components using a low melting point metal alloy called solder. It ensures strong electrical and mechanical connections. Proper soldering improves circuit reliability and performance. Common tools include soldering irons and flux. Good soldering practices are essential for quality electronic assembly. 23. What is noise in electronics? Noise is any unwanted disturbance that affects an electronic signal. It can be caused by thermal effects, electromagnetic interference, or component imperfections. Noise degrades signal quality and system performance. Techniques like shielding, filtering, and grounding are used to reduce noise. Understanding noise is crucial in communication and audio systems. 24. What is a communication system? A communication system transmits information from a sender to a receiver through a medium. It consists of transmitter, channel, and receiver. Communication systems can be wired or wireless. Examples include radio, television, mobile networks, and the internet. Electronics plays a vital role in signal processing and transmission. 25. What are the career opportunities in electronics? Electronics offers diverse career opportunities in industries such as telecommunications, automation, embedded systems, and semiconductor manufacturing. Roles include electronics engineer, hardware designer, PCB designer, and embedded developer. With rapid technological advancement, electronics professionals are in high demand. Continuous learning and hands-on experience are key to success in this field. That brings us to the end of our top 25 electronics interview questions and answers. If you've watched till the end, you're already ahead of many candidates. Revise these questions regularly, understand the concepts, and practice explaining them confidently. If you found this video helpful, don't forget to like, share, and subscribe for more interview-focused content. Best of luck for your electronics interview. You've got this.